Okay, I thought I'd go through a few minutes on this review. I'm not going to do everything, but if I can do a little bit to help you kind of get through this review, then I thought it might be helpful when you're studying tonight. The first four questions ask you to find the correct end behavior, and I'll just look at the first one. Right up here, it's 6x cubed plus 8x squared minus 8x plus 1. Let me pause this for a second and get this to where I can write a little bit better. All right, we're going to see if this works better. Okay, so what you do is you look at this this is my leading term. It's the one with the highest power. So if I look at 6x cubed, the sign of that leading term, whether it's positive or negative, tells me what it's doing on the right. So it's a positive 6, which means it's up on the right. The power of the leading term tells you whether it's going to be doing the same thing on the left and right or opposite things. When your power is even, like when it's quadratic or to the 4th power or to the 6th power, the left and the right sides of the graph do the same thing. But when they're odd, they do opposite things. So since this was an odd number, x cubed, it would have to do the opposite. I already know what it's doing on the right. This is the right. So that means it would be going down on the left. So rises to the right, falls to the left. And that's how 1 through 4 works. And the answers are on the back, so I don't feel like I need to spend any more time on that. Number 5, they want me to find the zeros of this polynomial function. F of x equals x to the 4th minus 20x squared plus 64. And state the multiplicities of each. If it can be factored, then that's what you need to do. So in this case, to get x to the 4th, it'd be x squared and x squared. I need two numbers that multiply give me 64 and add up to negative 20, which would be negative 4 and negative 16. That multiplies give me a positive 64 and adds together give me a negative 20. Now this can be factored again. It'd be x plus 2, x minus 2. And this can be factored again. It'd be x plus 4, x minus 4. So my zeros are negative 2, positive 2, negative 4, and positive 4. And they all have a multiplicity of 1, which means I'd have that factor one time. If I'd have two positive 4s, then I'd say that one has a negative 4 has a multiplicity of 2. It happens twice, but each one of these only occurs once, so they all have a multiplicity of 1. The next one, f of x equals x cubed plus 8x squared minus x minus 8. All right, 4 terms means you factor by grouping. Out of the first two, I can take out an x squared, and it'd leave me with x plus 8. Out of the last two, I can take out a negative 1, and it'd leave me with x plus 8. So now, the common factor is x plus 8, and the rest of it is x squared minus 1, which can be factored. So x plus 8 is a factor, and then this will be x plus 1, x minus 1 is how this factors. So my zeros are going to be negative 8, negative 1, and 1, and they all have a multiplicity of 1. And then finally, number 7, it's x squared plus 12x plus 27 squared. So basically, it's this twice. So when I factor x squared plus 12x plus 27, I get x plus 3, x plus 9. So my zeros are, and this should have an f of x in the front of it, my zeros are negative 3, whoa, stop, negative 3, negative 9, and again negative 3, and again negative 9. So both of these have a multiplicity of 2. Negative 3 and negative 9 with both with a multiplicity of 2 means they happen twice. 8 and 9 just ask about how many zeros can this have at most, what's the maximum number of zeros, what's the maximum x-intercepts, and what is the maximum number of turns. The way that the graph works, let's say I have 5x to the 11th, could go x to the 10th, x to the 8th, from that. But if this is the biggest one, then the highest power is the maximum number of zeros. Max of 11 zeros. That'd be a pain to have to find. It could also have a maximum of 11 x-intercepts. And then for your turns, it's that power minus 1, so it could have a maximum of 10 turns. If I have 5x to the 5th minus 4x cubed plus 2x squared plus 11, it could have at most 5 zeros. It could have at most 5 x-intercepts, and at most 4 turns. And that's how you do those problems. Alright, I'm going to keep on going until I get about 10 minutes worth of this video. Number 10 asks you to use the leading term test. It's x to the 4th power, which means it would have to be going up on the right because it's positive, and it'd have to be going up on the left because it's an even. So that would have to be D. That's the only one that's going up on both the right and the left. All right, number 11. F of x equals x plus 2 squared times x minus 1. They want to know what are the zeros and what are the multiplicities. If I set this equal to 0, I get negative 2, and because it's to the 2nd power, it has a multiplicity of 2, and I'd get positive 1. If I set x minus 1 equal to 0, I'd get positive 1. See, x plus 2 equals 0. I get x equals negative 2. X minus 1 equals 0. I get x equals 1. So 1 is a 0, and it just has a multiplicity of 1. That's 11. 12, a little bit harder. 12 is negative 6x squared times x minus 9 times x plus 1 cubed. Negative 6x squared means that 0 will be a 0. And that's going to have a multiplicity of 2 because it's squared, the x squared. And then you're going to have 9 once, and you're going to have negative 1 3 times. So that's how number 12 is worked. 13, you're going to have to factor. It's 3x cubed plus x squared minus 27x minus 9. Factor by grouping. X squared times 3x plus 1, and then minus 9 times 3x plus 1. It'd be 3x plus 1 times x squared minus 9, and x squared minus 9 factors to x plus 3, x minus 3. So my zeros are going to be, if you set 3x plus 1 equal to 0, you get negative 1/3. So negative 1/3, negative 3, and 3. 14, they want you to graph the function, 14 and 15. So 14 gives you 2x times x plus 1 times x minus 2. And what I would expect you to do is know that your zeros are at 0, negative 1, and 2. So when you're drawing this, that needs to be some key points on here. And then you're going to want to know, let's see, it'd be rising to the right. It's going to be cubic if I were to multiply this out, so it's going to be falling here. So you just need to find some points in between and draw a good graph. And you can use the table on your calculator for 14 and 15. But make sure that the zeros are notated in your graph. Okay, for the last 5, I may go a little over 15. If I tell you that negative 2 and 3 and 5 are zeros and I want the function, I'm going to multiply x plus 2 times x minus 3 times x minus 5. You can multiply any two together first that you want, but I'll do the last two. If you multiply x minus 3 times x minus 5, you get x squared minus 8x plus 15. That's x times x is x squared. The outers and the inners give you minus 8x and then plus 15. Now I do x plus 2 times all of this. It'd be x, if I do x first, x cubed minus 8x squared plus 15x plus 2x squared minus 16x plus 30. I would get x cubed minus 6x squared, put these together, minus 1x, and you don't have to put the 1, plus 30, and that would be what I would get for number 1. Number 2, they tell me negative 3 with a multiplicity of 2. That means I'm going to have x plus 3 and x plus 3 again. And then negative 2 with a multiplicity of 1. So that means I do x plus 2. And then negative 1 with a multiplicity of 1, which means I would do x plus 1. All right, if I'm going to do this, I'm going to do the first two together and the last two together and then multiply those two results together. So the first two would give me x squared plus 6x plus 9, and the last two would be x squared plus 3x plus 2. Alright, so I've got x squared plus 6x plus 9 is what I get when I multiply these two together, and x squared plus 3x plus 2 is what I get when I multiply these two together. So now, multiply all this times all of this. So I'm going to do x squared times all of this, which is x to the 4th plus 3x cubed plus 2x squared. Then I'm going to do 6x times all of it, so that's 6x times x squared would be 6x cubed plus 18x squared plus 12x. And then 9 times everything will be 9x squared plus 27x plus 18. So you get x to the 4th, and then put this together with this together, that's it, plus 9x cubed, and 2x squared and 9x squared make 11, and 18x squared would be 2 and 18 is 29x squared. And then I'd have 12 plus 27 would be 39x, and then 18. And that's what I get when I multiply that whole thing out. Alright, one more. I give you 1 plus the square root of 3, 1 minus the square root of 3, and 4. Okay, when you write these factors, if the 0 is 1 plus the square root of 3, your factor is x minus that. So that'd be minus 1 and minus the square root of 3. And this will be minus 1 and plus the square root of 3, and this is going to be minus 4. I would multiply these first two together first. You can do the last two, but it's going to get really yucky really fast. So I would do the first two together. So x times everything would be x squared minus x plus the square root of 3x. Minus 1 times everything would be minus x plus 1 minus the square root of 3. And then negative square root of 3 times everything will be negative square root of 3x plus the square root of 3, and then it'd be minus 3. And then I still have x minus 4 over here. Okay, combining my like terms here, I get x squared. Let's see. These cancel out, and these cancel out, and I get minus 2x when I put the minus x and the minus x together, and then minus 2 times x minus 4, which would be x cubed minus 4x squared minus 2x squared plus 8x minus 2x plus 8x cubed minus 6x squared plus 6x plus 8. And I went really fast on that, so you may want to slow it down, go back and pause it and figure out where all those things are coming from, but I don't want to run the time up too much. Alright, number 4 and 5 ask you to find the zeros. Alright, 4 can be factored. X plus 1 times x plus 1, so my zeros are negative 1 with a multiplicity of 2, because I get negative 1 twice. In number 5, it cannot be factored. There are not two numbers that multiply, give me 1, and add up to negative 5. So I'm going to do the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, because a is 1, c is 1, all over 2a. So that's 5 plus or minus the square root of 21 over 2, and I guess that's my answer. Let me check on the back. 5 plus the square root of 21 over 2. Yep, and 5 minus the square root of 21 over 2. So that's a quick overview of your review problems. Hopefully that helps. If you need any extra help, you can send me an email to angela.beeson@cabotschools.org.